Okay, today we're going to talk about factoring trinomials of the form above here. So the form above, we are now talking about this form right here. Okay, super important that we are locating A, B, and C. So the easiest way to do this is just go through quite a few examples showing you guys exactly how to factor one of these quadratic equations, okay, one of these trinomials. So let's just say we are given the first example, and of course, again, always starting with some of the easier ones. X squared plus 7x plus 12. Okay. Now, it says to factor a trinomial of the form above, you must find two integers that multiply to c. Okay, so what you need to note here is that first, I'm going to do it in the top corner. A is 1, B is 7, and C is 12. Okay, C is 12. You should be able to locate where A, B, and C are in the equation. So now we're going to multiply A times C, and A times C is 12. Okay, now A times C is 12. We need to find two numbers that will multiply to 12, but also add to 7, okay? So it's super important. A times C, that gives me 1 times 12, that's 12, and B is 7. So two numbers that multiply to 12, but add to 7. So now you gotta start thinking, what are two numbers that will multiply to 12, but will add to 7? And when you're factoring, what's good about this is, well, we know that x goes here, x goes here. Two numbers that multiply to 12 and add to 7, well, 6 times 2, that multiplies to 12, but that does not add to 7. 12 times 1, that multiplies to 12, but does not add to 7. The only one that possibly works here is 4 times 3. So we're going to drop in an x plus 4 here, x plus 3. So the purpose of factoring here was, now that we have our answer, our solution, this solution right here, when you FOIL it out, well, if you did it correctly, you're going to end up with the original problem, okay? And factoring is going to be super, super, super important in terms of the rest of your high school career. So it's important that you really understand what's going on here. I know it is the first example. So if you're really unsure of whether or not you did it correctly, take this piece right here, FOIL it, multiply it, distribute it out, see if you can arrive back at your original answer. And if you do, you did it correctly. If not, then maybe you chose some wrong numbers over here. Okay. I'm going to do a couple more examples. I'll leave A, B, and C up. Okay. Now again, each example is its own type of problem. So you're going to see multiple types of these. Let's see, x squared plus 2x minus 8. Now, A here is 1, B is 2, and C is negative 8. So now, A times C is negative 8, and B is 2. So we need two numbers that are going to multiply to negative 8, but add to 2. So, I'm thinking here, negative 4 and 2. Well, negative 4 times 2 is negative 8, so that works. But negative 4 plus 2 is equal to negative 2, so that doesn't work. But perhaps some altered way of viewing that would be 4 and negative 2. 4 times negative 2, that's negative 8, so that box is checked off. 4 plus negative 2, well, that's positive 2, so that box is checked off. So I know that my two numbers are positive 4 and negative 2. Again, if you get down here to this part of your solution and you wanted to check, I'll check this one for you guys just to show you how we can prove our solution to be true. Well, I'm going to go ahead and FOIL that out. See what I get. So, first, x times x is x squared. Outside is negative 2x. Inside is positive 4x. And last is negative 8. This is going to, our like terms are going to combine in here to positive 2x minus 8. This is the same as this, so we are good to go. All right, let's try another one here. Let's try another one. Maybe a little bit more challenging one. Let's see. Ooh. Y squared minus 17y plus 72. So again, A here is 1, B is negative 17, and C is 72. So A times C is 72. So two numbers that multiply to 72 but add to negative 17. I know that 9 and 8 multiply to 72, but 9 plus 8 is positive 17. So actually, what actually works here is negative 9 times negative 8. Negative 9 times negative 8 is positive 72, and when you add those two together, you can actually get negative 17. So here, be careful. They throw a y in, so it's y minus 9, y minus 8. And you can go ahead and check that solution up by foiling out again. Okay. We'll do two more, but what I want you guys to notice about the ones that I've already done here is the fact that your first rule of thumb with factoring is to try to locate if any of these functions have a greatest common factor first. Fortunately for us, the first three that we've done have not had a greatest common factor. So I'm going to throw in two examples where first thing you're going to have to do is locate the greatest common factor. You're going to need to factor that piece out. And then with the remaining piece that's left, you'll see that you're able to factor that even further. So, okay, after one iteration of factoring, you're not always completely done. So 4n squared plus 12n plus 8. And here's what I mean by that. Taking a look at this example, the first thing you're always going to do in factoring, always, is locate some sort of greatest common factor. If there is none, move on. That's fine. However, in this case, I can identify that the greatest common factor for all of these is actually 4. And when I take 4 out, I'm left with n squared plus 3n plus 2. Okay, so the greatest factor came out. And now what I'm really concerned about here is this piece right here. Okay, super, super important that we are not done. Just because we took the greatest common factor out does not mean that we are finished. So we are going to take a look in here. And now notice that we can actually factor this the way we've been talking about today. Okay. A is 1, B is 3, C is 2. So A times C is 2. So I need two numbers that multiply to 2, but add to 3. This one's super easy. It's 2 and 1. So then this 4 will drop in. And now I can rewrite like I have been. This is an n plus 2 and plus 1. And that right there is your final solution. Okay. And I will do one more of these. Also know that you can pause the video at any point if you're trying to figure out where some of these things are coming from. You can absolutely pause the video. Let's go into a little bit more of a challenging one. Let's see what we got here. That's a good one. Okay, this is going to be our last one. 5x squared minus 15x minus 140. Again, taking a look, greatest common factor first. Out of all of these terms, absolutely, they all share a 5. What I'm left with is x squared minus 3x minus 28. And now what I'm going to look at is this piece. Again, we're not done just by taking out the greatest common factor. Now we have to factor this the way we've been talking about today. A is 1 here, B is negative 3, and C is negative 28. So now I need two numbers that multiply to negative 28 but add to -3. What could those be? Well, I've been doing this for quite some time. So -7 and 4. Okay, -7 times 4 is -28. That works. And -7 plus 4 is -3. So that works. So then that 5 will drop in, and we can rewrite this as x minus 7, x plus 4. And that is our final solution. I should not be highlighting that in red. Bad choice. Yellow works just fine. Okay. And that is your solution right there. If you have any questions while you're working through these problems today, feel free to reach out to me. We can set up a time to meet as a class individually, whatever works best for you. This is one of the more challenging topics to learn on your own. I do understand that. So please reach out to me if you are struggling. And I hope that this video has helped you guys out.